This is a really awesome stage. So, I want to start out with a question. Who knows what my talk title means? Show of hands. Anybody? Anybody? One person. Come on. Thank you for that, sorry. So this is kind of the point that I want to make. We have all of these awesome security features, and it's not that people don't want to use them, it's not that people don't want to do security, it's just that we don't know they're there. And yes, they are security features, but they can also do some really awesome things for us. They can actually help us to fix problems, stop our users seeing errors, and stop us from making mistakes. So the sane version of my title would probably be something like this, Modern Web Security Standards. And this is what I'm going to be talking about today. So the rest of the talk will be kind of like 3 lightning talks on each one of these different topics, and they're the acronyms from the start of my slide title. I want to kick things off with the first one, which was CSP, and that is Content Security Policy. So Content Security Policy has been around for a very long time, and it was designed to fix a very specific problem that we had on the internet called cross-site scripting. You may have heard of XSS. Now, imagine this was your website. This is the home page of your website. Maybe you have a review section, a comment section, but somebody came along and typed in a comment, except the comment was a script tag. So this script tag would then be placed onto your web page. Now again, show of hands. Who wants this script tag on their web page? Nobody. And we can do that as humans. We can look at this and say, well, evil.com, that doesn't sound like a great domain, and the file is called keylogger.js. But the browser doesn't have that kind of information. It doesn't have the context or the understanding. The browser sees a script tag, and the browser loads the script tag. It does what it's instructed to do. This is the basis for a cross-site scripting attack. Somebody somehow has put script into our page that we don't want there. Now we can look at this one, and we've got the source attribute, we've got the domain and the path. What about this one? Now this isn't a particularly hostile script, but it's the same problem. Somebody has typed this into a comment or a review, maybe even a search field, and then it gets reflected back into the page. Now this would only pop an alert, but the browser's now got even less information. Did you as the host put this on your website, or has somebody else put this there for you? And again, the browser doesn't know, so the browser will just execute it. These are the 2 main reasons that CSP was invented, to try and combat cross-site scripting attacks, just like this, but CSP can also do a lot more for us. So to start to introduce you to CSP, Content Security Policy is a HTTP response header. You may be familiar with other headers. We've got cache control, server status, date, language, all of the ones you're familiar with. You just set another response header on your pages. And inside the response header, you put the policy that you want to be enforced on that particular page. Now the policy can be made up of a series of directives. This is a selection of them. This is not all of them. But what we can do is we can define something like the image source up in the top right. And then we define the image source, and we list all of the locations that the browser is allowed to load images from. So we literally just give it a list of domains. You can specify the font source and say, these are the locations you are permitted to load fonts from, nowhere else. And things get really powerful and interesting when we look at the script source. So let's take this and let's try and make a basic policy to show you what this would look like. We define the Content Security Policy header, and then we put our policy inside it. So I've used the default source here, which was on the previous slide, and if you don't specify things like script or style, they fall back to default. So I'm saying by default, all content can be loaded from self, which means my own website, or this other domain, which is my CDN. So now if we think about the script example from just a moment ago, loading from evil.com, that's already fixed, because the browser will look at the source attribute and say, okay, evil.com. Well, that's not in the source list. We're not allowed to use that. So the browser would refuse to load the script, and we've already fixed a very serious problem on our website. But we want to take control of more things. This is a very difficult policy to deploy, because I'm sure all of you, like me, load content from countless different websites. So we need to refine and tune our policy. So we may start with something like default source self. By default, I'm happy to load all of my content from my own site. But I then specified the script source. Now this overrides the default. So if you want to load scripts from yourself, you have to specify self again, and I also want to load scripts from these 2 other domains. That means that I can have script tags like this on my page. The browser will come to the script tag, check the source attribute against the whitelist, and say, yes, these scripts are permitted to load because they're coming from a site that's been whitelisted in the CSP. And then you go on like this, you fine-tune and build the policy for the rest of your site. Where do we load scripts, styles, images? Where do we fetch different types of content from on our website? Where is the browser allowed to load them? But CSP isn't just about fetching content. You can also control certain actions that the browser is allowed to take as well. So there's even more directives. I actually don't have time to cover all of them, so we're still looking at a subset. But I particularly like this one, the form action. Using content security policy, you can control where the browser is allowed to post forms to. So again, similar scenario. Maybe one of your developers has done this, your website has been hacked, but somehow there is a form on your website that says this. Do we want the browser to post our users' credentials to this address? And the answer is no. We don't. Hopefully the answer is no, we don't. So you can use the form action to tell the browser, you're only allowed to send forms back to me, nowhere else. Or maybe you do have some other places you send forms. You can specify them. Frame ancestors is a really good one. If anybody out there wanted to try and put my site into an iframe like this, the browser would refuse. Because in CSP, you can control who is allowed to put your website into an iframe. And if you've been involved in a migration with your site, like a lot of people are at the minute, from HTTP to HTTPS, you may have heard of something called mixed content. So you set up your website on HTTPS, and then you've got an image or a script or a style somewhere that's still on HTTP. The user will get an error in their browser, and there'll be warnings. Using block or mixed content, or preferably now upgrading secure requests, you can actually fix this automatically. So let's say we had this image tag in our page, and our website is HTTPS. The user would get some kind of warning in the browser, because the page is secure, but something in the page is not. Using upgrading secure requests, the browser will just automatically rewrite this script tag, this image tag for you. Any tag, it doesn't matter what the asset is. It would see this and say, well, we've got upgrading secure, so I'm going to make that HTTPS for you. Automatically, transparently, and it prevents the user from seeing a warning in the browser. So CSP is pretty powerful. There's a lot we can do with it. But say you deployed it and forgot to whitelist all of your style sheets. Your style sheets would be blocked and they wouldn't look very good. So we need a way to test CSP safely, and we have one of those as well. You can deploy the policy, same header, but it has report only on the end. And what it says to the browser is, tell me what you would do with this, but don't actually do it. I just want you to give me the feedback. And the browser will put error messages in the console and say, okay, if you gave me this policy, I would refuse to load this image. I would refuse to load this script, this style. And you can say, oh, right, we've missed something. We'll fix that. But this isn't very user-friendly. You have to go around your website with the developer tools open, looking at every single page. It's not very scalable. So we have a better way of doing this. And what you can do is actually ask the browser to send you a notification back. If you specify the Report-URI directive and provide it an endpoint, it will post a JSON payload back to that endpoint and say, hey, I came to this page on your website, the script source was violated, and it was trying to load a script from evil.com that you said shouldn't be there. And it will send you this report back in real time as your visitors browse around your website. And this is hugely powerful, because now everybody that comes to your website will let you know automatically and transparently if there's a problem on your website. So I want to give you a quick demo of a couple of these different things so we can actually see this in action. I prayed to the demo gods this morning, so this should work. And we have here a page. And what I'll do actually, if you find me on Twitter, I'll tweet out these links. So you can see this in real time. This is not, this is not kind of made up. These are actual real pages, real demos. So I have a form on this page, and let's take a look at it. Let's actually jump into the dev tools. So I can prove this is a real form. So we have a form here. Form action, evil.com steal password, username, password, and a submit button, right? Straight HTML form. There's nothing fancy, nothing trickery going on here. So I'm actually going to type my real username and password in here. There we go. What happens when I hit submit? Do we all agree that the browser should post this form according to the form? but nothing happens. And if I jump over to the console, and we take a look down here, the browser says, I refuse to send form data to evil.com. And if I move over, because it violates the following content security policy directive, form action. So the browser knows, even though this is a valid form and it's on your site and somebody has put it there, it's not allowed to send the credentials to that website, which we really don't want. So that's the form action. Same again with the script source. If we take a look at this script tag here, so let's have a look at this. We have a script tag here. Again, perfectly valid script tag, trying to load that keylogger file from evil.com. Don't do this on your websites. But again, if we take a look in the console, up at the top here, the browser has already said, refuse to load the script. Because according to my policy, I'm not allowed to load things from evil.com. It's not whitelisted. So the browser has automatically blocked that for me. And the really cool thing about all of these blocks, all of these things that happen, is that if I just reload the page again, we can actually see the browser reporting this back to me. So we have a post request here. And this is the browser sending the report to the address that I specified in my policy. And if we scroll to the bottom here, you can see this is the actual request payload. So the browser is reporting these actions in real time. It's saying, I've just come to this page on your site. Something happened that you said shouldn't happen. There's a script here that doesn't look right. Here is all of the information that you need to go and investigate that. And these are sent in real time by the browser. They're right here in the request tab in networks. And you can see keylogger.js was blocked because of CSP, and there's the report being sent. So this is a hugely powerful feature to have basically every visitor to your website scrutinize your website, look for problems, and then report those problems back to you in real time. Now, the service I use, full transparency, this is one of my services, but they're simple JSON payloads. All you need is some kind of endpoint or service to ingest those and then provide you information. So I can keep an eye on exactly what's happening on all of my different websites. And I think it was a few weeks ago, actually, I had a pretty big spike because I deployed something into production there. So I can just catch it. And there was a massive spike in style source. And what had happened is we'd embedded some content from Twitter, and we hadn't whitelisted the location where Twitter load their style sheets from. So straight away, we knew there was a huge spike in reports. We got an alert, and it's like, there's something wrong on your production site. So we went, we identified it, we fixed it, and as you can see, the next day, everything went back to normal. So this wasn't a security threat. This wasn't something bad happening. We just forgot about some styles, but we use CSP to help us detect that. So yes, they are security mechanisms, but it's not always about security. These things can genuinely help you in what you do. So that was a really brief intro to CSP. CSP is awesome. It's really powerful. Do go and have a look at it. There's also a lot more it can do for you. But in the interest of time and maintaining my lightning talk promise, we'll move on to the next acronym from my slide title, which was XXP, or Xss Protection. Now, XXP allows you to control the XSS auditor found in the browser. Modern browsers nowadays are super complex, and they've got loads of really great features. One of them, the XSS auditor, automatically looks at pages as your users browse your websites. And if the browser sees what it thinks is an attack, someone is trying to do something bad to that user, the auditor will step in and protect the user. It does this automatically. Now, I was going to talk about which browsers have good auditors and bad auditors, but the conference said that I wasn't allowed to say bad things about browser vendors. So I'm not going to say anything bad about which browser I think has the best auditor or not. That would be unprofessional. So we'll jump straight onto what XXP is. It's another response header. You set the XXP header, and you put your policy into the header. Now, XXP is super simple by comparison, because there's pretty much only three things you can do. You can disable the auditor, which I don't really advise. You can enable the auditor, which is actually the default setting in most browsers, or you can enable it and tell it to block all attacks. Now, I recommend the block mode because this is what I run on my sites. If the browser thinks there's an attack, yes, I would like you to stop that attack. But there's one more thing you can do, and again, very similar thread. You can ask the browser to tell you. If the browser at the other side thinks an attack is happening and is actually taking action to protect the user, I really want to know about that because that's very valuable information. So, again, quick demo time. Let's have a look at this in action. Very simple, very easy. So let's jump back. Whoops. No, I don't want to open the App Store. So again, I have a page here on my blog, and I'll tweet this, so you can come find me and actually go through exactly what I'm about to do right now. So I have a page here, and if I reload this page, you'll see that there's an alert, because there's a script tag on the page that pops one. It's a genuine script tag. I've put it there. Let's just prove there's nothing funny going on here. So where are we? It's in... I'm using a different resolution to usual. There it is. So we can see there's a script tag here, and it's literally just a script tag that pops an alert. It's supposed to be there, it's whitelisted, it's allowed, okay? But the really interesting thing is, if I take a copy of this element, if I go up to the address bar, and I just make up a get parameter, equals, and paste that script tag, and then hit enter, where's my alert? There's nothing going on the server side. This is just a static HTML page. There's no fancy business. You can go check the tweet. But what's happened here now is that in that get parameter, the browser can see a script tag. But the browser can also see that script tag in the DOM. So what the browser thinks has happened is that because we've sent the script tag to the server has then rendered that back into the page. We call it XSS reflection. The script tag is reflected back into the DOM. And if you look here, because the browser thinks an attack is happening, the browser has modified the script tag and said, well, I think this is fishy. I think there's an attack going on here. And this is a simulation of an attack. And the browser has correctly taken action to protect the user, me, the person at the keyboard. And again, just like before, we can jump over to the tab and see that we have reports sent. So down here, we've got an XSS payload, slightly different JSON payload, but the same thing again. The browser is saying, hey, I just had to protect one of your users because they were under attack. Here is all of the information that you need. This is really powerful stuff. This is really, really interesting. So what happened on this page here was that the browser just took the script tag out. You could see that it edited the tag. But I have exactly the same page again here, but now the auditor is configured to behave slightly differently. On this page, I've configured the auditor to block everything. So again, I've just sent the tweet if you want to have a look at it. I'll reload the page. You can see there's my script tag with the alert. And I'll jump into the inspector. Where's my script tag? Here it is. So again, exactly the same script tag, exactly the same thing as before. And what I'm going to do, I'm going to take a copy of this. I'm going to go to the address bar, make up some get parameter, paste that in, hit enter. But this time we get a slightly different response. This time you can see here the browser has said, blocked by the auditor. So this is the difference between the two modes. When you enable it with just one, the browser will filter out the script that it thinks is hostile. If you go to mode block, it will actually block the payload. And this is a slightly more strict approach, but I kind of want the browser to say, look, if there's an attack and you think something genuinely bad is happening, let's just stop. Let's not try and fix it because maybe we'll get it wrong. There are cases when the auditor's been tricked. But you know what, if there's something wrong and you genuinely think one of my users is being attacked, let's just stop everything there because we probably shouldn't continue. So this is block mode. This is the only difference between the two. And we recommend it because, like, genuinely, if one of my users is under attack, I'd rather that we just stop and figure out what's going on than let them carry on and try and fix it. So that's most of the XSS stuff there. And again, we have all of those attacks that I just showed you will have been logged and reported to me in real time. So you can actually monitor these, you can create alerts, you can get all the information that you want. And if we go to the reports tab, we can probably see the ones that I've literally just triggered now. So here. Yep, so there you go. Literally, these are the ones now. It says 9:37 because I'm an hour behind in the UK, so that's actually 10:37 here. So those are literally the attacks that just happened on my website. The browsers reported them, we ingested the JSON, and now you have them in your dashboards. If this was a legitimate attack, you would already know that it had happened within seconds of it happening. So again, XXP is hugely powerful. Most of the browsers actually have the auditor enabled by default. So whether or not you know it and whether or not you want it, the auditor is already doing most of what I just showed you. So you should take control of that, explicitly configure it, and also ask it to send you the reports back as well. So next up, third acronym from my slide title was STS, Strict Transport Security. And STS is pretty much the biggest bang for buck you're going to get on a security feature. You need to use strict transport security if you have this on your website. If your website is served over HTTPS and you redirect your traffic there and make people use HTTPS, then you should be deploying strict transport security on your website. One of the really good things that we've seen recently is just this explosive growth of websites going from HTTP to HTTPS. I scan the top 1 million websites on the planet every 6 months and produce a report. This is the data from the report. And what this shows is the percentage of sites in those top 1 million that redirect you from HTTP to HTTPS. And not only are we continuing to increase this number, you can see the graph is actually getting steeper. We're actually converting more sites more quickly as well. So we're on a huge migration path towards HTTPS on the web at the minute, which is a good thing. We want secure communications. But there is one thing that we need to consider, and HSTS, or HTTP Strict Transport Security as we call it, fixes what is still to this day in every single browser a pretty fundamental flaw. So imagine a browsing scenario. You open your browser, you want to go to Twitter. What do you type into your browser? Twitter.com? Well, is that fair? Would everyone here type in twitter.com to go to Twitter and then hit enter? Right, that's pretty fair, okay? That's what I do, it's what everybody does. But is twitter.com a valid URL? It's not, it's just a domain. The browser needs to make it a URL to go there, and the browser does that by pre-filling HTTP:// because HTTP is still the default protocol of every browser on the planet. So you give it twitter.com, and it has to add something, and the something it adds is HTTP. So what that results in is you actually making an insecure request to Twitter. Now, Twitter is a very good website. They have HTTPS deployed, so they will respond back with a 301 and say, no, we don't do HTTP. We do HTTPS, so please come back on HTTPS. And the browser says, of course, sure, there we go. Get request on HTTPS. Now we're secure. We've got green padlocks. Everything is good. But there's a really big problem here. And the problem is that the first part of this conversation actually exclusively took place on HTTP. And the 301 redirect is the thing that tells us to go from insecure to secure. And we sent that over HTTP. Now, HTTP is not secure. It means that people can modify it, people can tamper with it, people can change it. So the upgrade indicator, the thing that says, this is not secure, go be secure, is actually not secure and can be changed and altered. And this is a really trivial attack. And what happens, essentially, is something called SSL stripping. This has been around for quite some time, but basically an attacker can intercept those first HTTP requests and essentially proxy them to Twitter on HTTPS. Now, if your browser never gets the 301 redirect to say go to HTTPS, how does it ever know that it was supposed to? And the answer is that it can't. This is a problem because this is super trivial to do, and it essentially undoes all of the hardship that we did putting HTTPS onto our website. So to fix this problem, we have strict transport security, which, to maintain the theme, is another HTTP header. You issue the strict transport security header, and you put your policy inside it. Now, the policies for STS are super simple. These are the only directives that we have. And the only one that's actually required for a valid policy is max age. Now, max age is the number of seconds that the browser must cache and apply this policy for. Include subdomains does exactly what it sounds like. Apply it to the current domain and all subdomains underneath it. And I'll talk about preload in the demo section. So, minimum viable policy is this. Strict transport security, max age equals, and then a number of seconds. This is 1 month in seconds. And if you deploy this onto your website, what it tells the browser is that all communication to my site must be secure, no matter what. It must be secure. So if you were to deploy this on your site, like Twitter does, when you open the browser and type in twitter.com, what actually happens is the browser knows not to default to HTTP. The browser knows instead that it should default to HTTPS. And the really interesting thing with this is, even if you manually type in HTTP:// as the user at the keyboard, the browser will override you, and it will force the connection to be secure. So now, all of our communications take place on HTTPS, so we can just throw that first one away because it doesn't even happen. Now the attacker has no way to get into our communications. And if you're interested in performance, you've also saved a full network round trip that is no longer present. So this will actually make things faster as well. So let's take a look at this in action and what we can do with this. Ooh, there we go. So strict transport security, super simple. Where's mine? I'll show you on my site first. So I'm going to open up the dev tools. Let's go to the network tab, clear that, and preserve. So I'm going to specifically type in http://scotthelm.co.uk. So I'm trying to force the browser to go to HTTP. Now, of course, it was redirected, but the interesting thing is that if you take a look at this, it didn't actually send a request over the network. In Chromium, they have what's called a 307 internal redirect, where the browser knows this is a HTTP request, but because I already have STS enabled on my site, the browser will actually redirect that internally. And you can see that the next request was a GET request to HTTPS. And if you look at the waterfall, you can see that there's no way that that went out on the network, on the Wi-Fi, to my server and back in 13 milliseconds. All of this happens locally on the device. So we've just shaved a significant portion of my load time and made things more secure. Now, if we look at a website that also uses HTTPS, but is not using strict transport security, so shh, don't laugh, that's mean. I was debating whether or not to use the conference website. So I'll force it to go to HTTP. And of course, as you would expect, we end up back on HTTPS. But here, look at the first request. It is an actual GET request on HTTP. It went out on the network and got a 301 from the server. And that meant that we were doing insecure communications out across the Wi-Fi here, which is a really bad idea. And then it got the redirect to come back. And then the next request in the browser was the secure GET request. So we had that first request was not secure. And when your first request is not secure, everything after it is also at risk. So we have to lock down that first one. Now, I said I was going to talk about the preload directive. Last thing, HSTS STS has what we call a tofu problem, which is trust on first use. If you've never been to my website, your browser can't know that I've got STS enabled, right? You've got to go there at least once to see that I have it turned on, and then you can remember after that, which means that your first connection is at risk. But we can actually fix that. So if you include in your headers, and I can show you this on my website, oh, is this one here? There is a preload token in the header. So here's my STS header, and I have the preload token at the end. Now, when you add that to your header, what you're saying is that you give permission to join this. It's the HSTS preload list. And if you go here, you can submit your website. If you meet the criteria, which means you have to have that preload token to give consent, you get your domain name added to the list. So this is quite literally just a big list of domain names that have requested and gained approval to join. The really interesting thing with this is that every single major browser vendor in the world takes a copy of that list and bakes it into the source code of their browser. So the really cool thing is, even though most of you here have probably never been to my website, I know that my domain name is literally hard-coded into all of your devices because I'm on the HSTS preload list, and the preload list is included in every mainstream browser on the planet. So if we take a look, there's me, literally baked into the Chromium source. So preloading is awesome. It's really good for security. Last thing, and then I'm going to wrap up. If you want to make sure that you're doing features like this correctly and learn about all the others that I didn't have time to talk about, check out this website. You can come, scan your domain. It will tell you if you're using these features, if you're using them correctly, which other ones you can use. So the tools are out there to give you this information. Check them out, use them, and that's pretty much everything for me today. So thank you very much.
Thank you, Scott.